Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So in this video class, I am going to teach you about push down automata. Simply that is called PDA. PDA, that is nothing but push down automata. Okay. So this is another type of machine. So we studied a few machine like finite automata, the types of finite automata, NFA, DFA. Okay. So this is one type of machine. So in order to run this machine, we simplified this term called regular expression that I taught you in the second unit. And now this is the next machine, that is push down automata machine, PDA machine. Okay, so you know the method of or model of finite automata. Right now, I am going to teach you the model of push down automata. So let you think this is the automata, but push down automata. So here the difference between finite automata and push down automata is, finite automata is an ordinary machine. We cannot store the input. We cannot store the input. Okay, we cannot store the input. But the features of PDA is we can store the input. We can store the input. So you know, whenever you need to store the input, we need some buffering techniques, buffering concept. But I told you, finite automata, no need of buffering. So it reads the current input, and it reads the state, and it perform one action. Okay, but it doesn't know the previous input and next input like that, because it is not storing the inputs, the states. But PDA, it can store the input. So it needs some buffering concept, buffering techniques. That is nothing but we can use stack. Okay, so the difference between finite automata and PDA is, in PDA we are going to use stack, but finite automata there is no stack. So why we are using stack is in order to store the input. So what is the use of storing the input is, it can remember the previous input or next input like that. But in finite automata there is no stack, so it doesn't know the previous input or the already stored input. Okay, so this is the feature of finite automata, features. So another one feature added. Okay, so sometime in some questions or one word questions, you have to understand, finite automata there is no stack, but PDA there is a buffering concept that is called stack. Clear? Okay, so now I am going to teach you the definition of PDA. If you know the definition of finite automata, then it is easy to understand the definition of PDA. Okay, so finite automata have how many tuples? Capital Q, that is finite automata. Capital Q, sigma, delta, Q0, F. Okay, this is finite automata. But in case of PDA, it has one more tuples. Why? Because here we are adding one more feature, that is called stack. So one more tuples is there, that is capital Q is there, M equal to, and sigma is there. Capital Q means it is a finite set of state. Sigma is finite set of input symbol. And delta, that is transition function. One more symbol, that is row. Okay, row is there in PDA. What is the use of row is finite set of stack symbol. That is stack. We are going to store some symbols inside the stack. That symbol will represent as row. And Q0, F. Okay, Q0 is a starting state, F is an accepting state. So one more feature in a PDA, that is called row. Why we are using row is, it is a stack symbol. Except everything is same in finite automata. Q is a finite set of states, finite set of sigma is a finite set of input symbol, and row is a transition function. Some function should be different from PDA and finite automata. That should be represented by delta. Row is a stack symbol, Q0 is a starting state, F is an accepting state or final state. Okay, this is same as finite automata. Okay, so I am going to explain you the method and model of PDA. Model of PDA means how push down automata is going to be work. That should be represented by a simple diagrammatic representation. That is called, see, this is the model. Okay, Here I told you it uses, this is called stack. It uses stack. Okay. So stack means, first in last out or last in first out. The operation, right? See, if a first input comes, it store here. I can take last only. So first in last out. Okay. Stack, and this is called input symbol. This is input symbol. Finite number of input symbol I can store from this side and this side. That's what I am representing here. This is finite automata. This is a PDA algorithm. PDA algorithm, right? PDA algorithm. That means state. So now it represents the input stack point symbol, and stack also it points the stack symbol. Okay. So how it is going to be work is, you read the stack symbol and it read the input symbol, the control moves to another state. But in example, delta of q comma a equal to q1, this is finite automata. It read the current state and it read the input symbol, then it goes to another state. This is PDA. But here it read the current symbol and it read the stack symbol and it read the input symbol, then it goes to another state. For example, delta of q comma q1 comma x comma a equal to q2 comma b or something. Okay, something. So the thing is, x is added. The compared with the finite automata, we are going to add x. Why? Q1 is a state. It read the state. You read the state, current state, and stack symbol and input symbol, and goes to another state with one symbol. Okay, so this is the model of PDA. So you just remember, transition diagram should be delta of q comma x comma a equal to q2 comma a, like that. This is the transition model. But in finite automata, delta of q comma a equal to q1. That means current state comma input symbol. But here it is adding another one stack symbol also. Clear? Right. So this is the model of PDA. So you just remember, state, it takes input symbol as well as stack symbol, and it going to be next state. But in the previous model, state as only the input symbol and going to be next state. Okay, this is the model of PDA, and this diagram you should draw, and then you have to explain this diagram. Then the definition is m equal to capital Q comma sigma comma delta comma rho comma q0 comma f. Okay, capital Q is a finite set of states. Okay, and sigma is a finite set of input symbol, and delta is a transition function, and rho, this only different from finite automata. Rho is a you have write like this. Okay, rho is a finite set of stack symbol, and q0 is a starting state, and f is an accepting state. Clear? So this is the model of finite PDA, push down automata. We are going to see some problem. The next video class I am going to teach you the problem of finite automata. Okay, thank you.